Hello friends, myself R.D. Mazen presenting my video on the topic Fourier series for an odd function. Example, find Fourier series for the function f of x is equal to pi into x in the interval minus pi less than x less than equals to pi. Here the given interval is minus L to L type. Therefore, we can check the function for even or odd, whether it is even or odd function. Therefore, f of x is pi x. Replacing x by minus x, we get f of minus x as pi times minus x. We get minus pi x. It is minus of f of x. And therefore, it is an odd function. And as it is an odd function, Fourier series coefficient A0 is 0, an is also 0, and bn is obtained by or given by 2 by L integral from 0 to L f of x into sine of n pi x by L and its integration with respect to x. And therefore, we try to find out the value of bn by applying this formula. A0 is 0, an is also 0, and that bn is given by 2 by L integration from 0 to L f of x into sine of n pi x by L and its integration with respect to x. And therefore, it is 2 by L, the value of L is here pi, integration from 0 to pi, f of x is pi x multiplied by sine of n pi x by pi get cancelled, we get sine of nx. And therefore, it is 2 times integration from 0 to pi, this pi and that pi get cancelled, remaining terms are x sine of nx it is a product of two terms of x. First one is x algebraic type and second one is sine of nx trigonometric type. Therefore, this must be the first and sine nx we consider second, and then integrating it by generalized part, we get first term x integration of sine minus cos of nx divided by n minus derivative of x with respect to x 1. Its next integration is sine nx by n square with minus sign, and next derivative is 0. We stop here and limits from 0 to pi, and therefore we get 2 times. When we substitute upper limit, we have the two terms sin n pi and cos n pi. The value of sin n pi, we know that it is 0, and cos of n pi, its value is minus 1 dash to n, and therefore this becomes minus pi. Cos of n pi is minus 1 dash to n divided by n, minus minus plus, sine of n pi is 0, then minus for the lower limit, when x is 0 that term becomes 0, and sine 0 is also 0, and therefore we have that value as minus 2 pi minus 1 raised to n divided by n, value of bn. Then substituting these values in that Fourier series result, we have the values a0 is 0, an is 0, and bn is equals to minus 2 pi into minus 1 raised to n divided by n. Substituting all the values here in equation 1, we get the Fourier series. F of x is here pi x, a0 0, an 0, bn, the value of bn is minus 2 pi minus 1 raised to n divided by n into sine of nx, n changes from 1 to infinity.